In our first section of the new semester for geometry, we're actually going to take a step back and go back to section 1.3. We've already done a piece of section 1.3, but we need to do the other part, which is to add the formulas, the midpoint formula and the distance formula. The first thing that I want to take a look at is just a simple example of talking about the middle or the midpoint. So for instance, I have the number 5 and 7. What is in the middle of 5 and 7? Well, I know that it would be 6. 6 is in between 5 and 7. It's right in the middle. But I need another method, another way, so if I get something more complicated, I can figure out what's in the middle of two numbers or 2 points. So one method that I could use is to take these two and find the average or find the middle. So if I take 5 plus 7 and divide it by 2, I also get 6 to find that middle or to find that average or to find that midpoint. Well, we're going to actually take that same concept and use it in the midpoint formula. So here is the midpoint formula, and similarly, just like we did, we're going to take and we're going to add two numbers and divide by 2. The only difference is that we're going to do it 2 times because we have the x values to worry about and we have the y values. So we have to account for both of those. Notice in this formula too, we have 2 big parentheses here because the actual midpoint is a point. It's going to have an x value and it's going to have a y value. Okay, so let's look at an example. So here is an example of 2 points. I have the point 1, -3 and the point 4, 2. And I'm going to use that formula to find what the middle is. I also took a look at it on the graph to see if I just graphed these 2 points here, how would I know exactly where that middle is? Just by, can I see it by looking at the graph? And I really can't. If I want to really be precise, I need to use this formula. So I am going to take my x values. Like we said, I highlighted those in yellow, and that's 1 and 4. I'm going to add them together and divide by 2. And then I'm going to take the y values, which is -3 and 2. I'm going to add those together and again divide by 2 to find that middle piece. So I can see 1 plus 4 is 5 divided by 2, and -3 plus 2 is -1 divided by 2. I could leave it like this, 5 halves and -1 half. It might be easier to see though, the number 5 halves can also be written as 2.5 or 2.5, and this of course could also be written as -0.5 as well. And you can see as I look, this is right about where that point would be. But I would have had trouble finding it on this just from a graph. I really needed that formula in this piece to find out exactly where that midpoint is. Now, the next formula we're going to take a look at today is called the distance formula. And it relates, I'm going to draw just kind of like a little side story here and kind of show you where this comes from. If I'm going to find the distance from this point to this point, for instance, on a graph, I'm not just going to be able to count these places. On a graph, I would be able to count across the y, or excuse me, across the x, and I would also be able to count the y. I can count across and I can count up and down, but I can't just count diagonally. That's kind of a problem. But if you notice, from here across and here down, notice what this creates. It creates a right triangle. And if you remember, there is the Pythagorean theorem that says a squared plus b squared equals c squared. So because it kind of creates this right triangle, I can use kind of a derivative of this Pythagorean theorem to help me find the distance from here to here. And it works kind of simply like this. If this is the x values, I need to find out how far from here to here. How far is this? And then my y values, how far from here to here. And if I know those two things, that can help me find the distance of this hypotenuse or this line segment that we're trying to figure out. So here's what the distance formula looks like. It's kind of like that a squared plus b squared equals c squared, and I really messed up. I was trying to make this darker, and this got a little bit crazy for me. But this is a big radical. It's a big square root sign. And inside of it here, you can see this parenthesis, and inside this parenthesis, I'm going to take the x's and subtract them, and then I will square them. And then I'm going to add that to this parenthesis here, which is the y's. I'm going to subtract the y's and then also square those. Do you see where this a squared plus b squared equals c squared piece of it comes in? To find the solution, when I take that radical, it will give me that solution. So one other thing to remind you of again are these subscripts. Remember, the subscripts just mean that I need to kind of go in the same order and be consistent. So I'm going to show you that. So don't let those subscripts get too crazy. I just subtract the x's and I subtract the y's. So let's do an example of that. So here is an example that we're going to put into our notes. And here was the example, 0.23 and the 0.4, -1. So I chose, in my example, to do my x's here, and I chose to take 4 minus 2. I could have taken 2 minus 4, but I chose to go 4 minus 2. Not really any rhyme or reason that I had to do it. I just kind of like when things are positive, so that's why I went that direction. But because I went 4 minus 2, now for the y's, I have to start here and go -1 minus 3. So when I do that, 4 minus 2 is 2, and -1 minus 3 is -4. 2 squared, 2 times 2 is 4. -4 squared, -4 times -4 is a positive 16. So once I figure out my little solutions here, then I have my final radical. So I come up with the square root of 20, or if I put in my calculator and put the square root of 20, I get approximately 4.5. So that would be the distance from here to here. That's how far that would be, approximately 4.5.